here's how we determine the range. We imagine that we try to cut this graph with horizontal lines starting from negative infinity and going to positive infinity. Just imagine that you do this and tell me where the function exists.
The lower range would be -3.
With a parenthesis. Very good. Awesome.
Q1.
Good. With a parenthesis or a bracket.
Parenthesis.
Good. Union.
Two.
Very good. It's only one element. When it's one or finite number of elements, I have to use braces. Union.
Four.
With a bracket. 2.
Infinity.
That's it. Perfect. And now we have 4 minutes left. Don't you ever, it's not your fault, of course, I'm just saying. Please always have the courage to tell me or stop me if it appears that I'm going over the time. So
measure the radius again. Sorry, the range.
As a token of respect, I have to end the class when I should. So.
Thanks.
Okay, so 4 or 3 or 4 minutes left. So choose anything else. The rest, I'm sure you can see them in a. Yeah, I want to talk about G here, arctangent. This is a function that it will come back in limits, in derivatives, in everywhere. So let's talk about that. So let me refresh your memory on how to graph. It's this one here at the top. It's 4G, arctangent x. Arctangent x. So f of x equals arctangent x. So let's refresh our memory on, if this is not a good color, always tell me. Sorry about that. It's not a good color. If it's not visible or something, please stop me and I'll discard those. Okay, so let's start with tangent x. Tangent x is a function that has problems. Because it's a ratio. So tangent x, can anyone tell us what ratio is tangent x?
It's the opposite over the adjacent.
Right. Opposite of the adjacent. Excellent. Also, very good. So whenever this is 0, it creates a problem, undefined. Where is this 0?
Zero at 1.
Where is cosine 0? Exactly. Pi over 2 and 3 pi over 2. That's where cosine is 0. So what happens at that point? So cosine is 0. I'm just going to write one period this time. So at pi over 2 and 3 pi over 2. So when x is 0, forgive me, when cosine is 0, the denominator is 0 at these 2 points. So this must be pi over 2, and this must be 3 pi over 2, and this must be negative pi over 2, and negative 3 pi over 2. There is a vertical asymptote there. So when the denominator of a fraction is 0, the function or the fraction is undefined. And in this case, it changes into a vertical asymptote. or asymptotes in this case. So, what quadrant is between 0 and pi over 2?
1.
Yes. So this is the first quadrant. What quadrant is this? Between negative pi over 2 and 0.
3.
Right? 1, 2, 3, 4. 1, 4, 3, 2, 1. 4. So then the graph is this. And of course it repeats itself indefinitely, and so on and so forth in both directions. Forever. So this is the graph of tangent x. This is the inverse of tangent, also called tangent inverse. They are the same. This is arctangent and this is tangent inverse. Okay, so I'm just there on the, so these two vertical asymptotes move horizontally. And this is the graph of arctangent. So the red graph, arctangent. So I want